All right, so the inverting amplifier is a rather simple topology. So we have our amplifier, looks like this, and we ground the positive terminal. And this is our output, V out. Make sure to draw my ground. And then I'm going to feed back using resistor RF and RS. And I'm going to go ahead and put my input right here as a voltage source, Vn.
Cool.
Okay, so let's use rule number 2 because we have V plus grounded.
Okay.
And we know, because of rule 2, what's that say?
They're the same. V plus equals V minus.
Exactly. And in this case, since it's ground, that's 0 volts.
That's sometimes called a virtual ground, by the way.
Yeah, since this isn't actually connected to ground, but it is forced to ground.
Right, exactly.
Yeah, we can call this the virtual ground.
That term, for those of you at home, that term is used in a variety of different contexts, but this is one of them. Okay, so now we know that V minus there is ground. Okay, what are we going to do next?
Okay, so let's go ahead and try doing KCL. Let's do KCL at this node. We'll call it node A.
Okay.
Okay, so let me first label the currents. We have IF, we have IS, and we have IN.
Aha.
So we got these 3 currents, and we know, what do we know from KCL?
So IF must equal IS plus IN. That's
Exactly.
one way to do it.
But we know from rule number 1 that IN has to be 0.
Aha. Okay. This is getting easier and easier.
Easier and easier, yeah. We just have the feedback currents the same as the source current.
Okay. So the source current's going to, all the source current's going to run through the feedback path.
Exactly. So it runs like this.
This is a thing that comes up over and over, this motif. Okay. So I have a sense that we can now write what the currents are in terms of voltages.
Yeah. So, okay, what's IF? Well,
IF is V out minus V minus, which is 0, divided by RF.
Exactly.
And IS is going to be V minus, which is 0, minus Vn
That's right.
over RS.
Exactly.
Awesome. Aha, so now we can get rid of the zeros and write an expression for the output versus, as a function of the input.
Yeah, let's go ahead and simplify this a bit. So that's equal to minus Vn over Rs. And now, why don't we go ahead and get V out as a function of Vn? Let's do that.
Yeah.
So V out is equal to, I'll just multiply by RF.
So RF over RS.
Minus RF over RS.
Times Vn. Oh, okay.
Times Vn.
So you see very quickly the output is, the resistors set the gain, right? So the output is a function of the input by a linear factor, and that's minus RF over RS.
In fact, we had a term for that, right? G we use for the closed loop gain. That's V out over Vn.
And that's minus RF.
In this case, it's minus RF over RS.
So you just pick your 2 resistor values. You can get a gain of 1, a gain of 2, a gain of 10, whatever you want. And it's always got a minus sign. That's why it's called inverting.
We've inverted it. Yep.
Cool. Let's try the non-inverting amplifier.
All right.